Hi everybody, Steven here. So you need to know what vSAN is, or VMware vSAN. Well, stick around. This is going to be a multi-part series where we talk about what vSAN is. We'll start with the basics. We'll look at how to set it up. We'll also look at how we manage it as well, right? And we'll talk about storage policies. But for now, this is what is vSAN. So basically vSAN 101. Stick around. We'll see you in a bit. Thanks for sticking around. What we're going to do, as I mentioned before, this is going to be a multi-part series. This one here is just going to talk about what vSAN is, get everybody on the same page. My next video will be setting it up. I got a couple of things on that. So anyways, I like to throw this out there at this point, and thank you very much for you subscribers. Really appreciate the support. If this is content that you kind of like or are interested in, please support the channel by subscribing. Without subscribers, there's no content, right, folks? Also, the other way to support the channel, there's super thanks is available. Totally up to you. Let's get started, okay? Let's go to my iPad. This is a lecture-only component. I'll do a demo one will be released probably in the next few days. So what is vSAN? So this is basically, I'm referring to vSAN 8, but a lot of this stuff is pretty much the same. I'll kind of point out what's new in version 8, but this has been around for a while. So vSAN is an enterprise storage virtualization software that supports the hyper-converged infrastructure. So basically what it is, it's a way for us to virtualize our storage, right? So imagine you've got, you want to set up some kind of shared storage solution, like in VMware, to take advantage of stuff like vSphere's HA, DRS, vMotion, all these really cool things, HA, all this stuff, right? That typically requires shared storage, and one of the easiest ways to do that is use what's called a storage area network. I'll probably put together a video or series on basic storage area networks, but in a quick nutshell, is you've got a bunch of servers, and they have some kind of adapters, maybe they're Ethernet or fiber channel or whatever. You'll have some kind of, let's say, I'm more of a fiber channel guy because that's what I played with a lot. You may have a fiber channel network, right? That type of thing. And then you got some kind of storage solution over here, okay? And then you've got maybe a bunch of racks, of disks, right? And maybe they're all pooled together to give you like RAID 1, RAID 10, RAID 5, whatever the case may be. I don't care. So these disks now, or these volumes that are created down here in the storage, can be visible to your servers up here, and then you can format them with the VMFS file system. So now these servers, all these 4 servers up here, can have access to those volumes, right? Shared storage. The problem with this is it can get pretty expensive. Also, you got to kind of know what you're doing here, right? I've played with this stuff for many, many years, but not everybody has. Not everybody knows what fiber channel is, and zoning and masking and all that stuff. So vSAN basically allows us to use our internal storage and create a virtual SAN, a virtual storage area network, right? So this is built in as part of the ESXi hypervisor. It creates a single pool of storage from local or direct attached devices, which I'll actually show you, okay? So it gives me the ability to take my local disks and pool them together, I'll say, to appear as a shared storage among many servers. And we'll take a look at that, right? Eliminates the need for shared storage. Just like I said, you don't really need to have a fiber channel network or anything. You can just take advantage of this. Now, it talks about storage policies here. Some of you may be familiar with this. Storage policies is how do we protect our VMs? How do I, do I want to do encryption? Do I want to do deduplication, that type of stuff? How do I want to protect it? Do I want to do RAID 1, RAID 5, that sort of thing, right? We'll take a look at storage policies, and we'll touch on them a bit here, but I'll do a more detailed hands-on video on storage policies because we can spend a bit of time on that. Simplify storage configuration and VM provisioning. Yeah, I'll agree with that. Again, if you know nothing about like storage area networks, like somebody throws a bunch of fiber channel storage at you and switches, and you're like, I don't know what to do with this, right? This simplifies that, so you don't really need to worry about all those pieces, right? If you know vSphere, setting up vSAN is not really a big stretch. It is a shared storage solution, so it supports features, all these cool things, what we want shared storage for, like vSphere's high availability, distributed resource scheduling, DRS vMotion, all these kind of wonderful stuff. We enable this on a cluster, and a single data store is created. Now, that's the part that you may have to wrap your head around, because a lot of times you may be in a real world creating multiple data stores and stuff like that and putting VMs on those data stores, which is fine. But vSAN, you're just creating one big data store, right? But underneath the covers, it's not really like that. It's actually running across multiple disks, right? But it does simplify things. Now, it manages data in a form of flexible objects. So the vSAN file system is basically object oriented. So your virtual disk, the file that makes up your virtual disk, like your VMDK, your virtual machine snapshot files, the home directory, the virtual machine swap file, all those are objects on a vSAN data store, which is kind of transparent to you, to be honest with you, right? And we'll take a look at some of these objects in another video when we get a little bit deeper down underneath the covers. So now, I mentioned before, it allows us to take our disks from our servers and kind of pool them together. So right here, if you look here, I've got 4 servers in this picture here. I'll call that server 1, server 2, server 3, and server 4. These are physical servers, right? They've got a boot drive, so maybe I got some disks there, it's booting from. I don't care. So it's running ESXi. So it's booting from that. But then I actually have some internal disks. So each of these servers, these 4 servers in this picture, will have some disks. Now notice I'm showing you an SSD disk here, and then I'm showing you just magnetic disks, spindle disks. So we can do that. We can actually pool these together to act as one big volume. And you kind of see that. We're actually taking all these, pool them together to make one big vSAN data store. Now, one of the things you'll notice, I got an SSD, and I call that caching. So this solution is what they call a multi-tier. There's a cache tier right here at the top, and then there's a capacity tier. So the cache tier in this example, we use it for 70% reads and 30% writes. So this, we know magnetic disks are slow compared to like solid state, right? This could be SSD, NVMe, that sort of thing. So basically any of the writes will go to the actual solid state disk and then out to the physical disk afterwards, right? So a concept that we have to get here is this thing called disk groups. So within vSAN, actually before I even mention that, in this case here, we're talking about a hybrid disk group. You'll notice I got SSD for my cache tier, and then I got normal hard drives or mechanical drives for my capacity tier. So 2 different technologies. This is why they call it a hybrid. Now, when we create a disk group, you'll have a disk group needs it needs a cache disk. So it needs at least 1 solid state disk. Then after that, you can have since we're talking about hybrid, you can have up to 7 mechanical drives in a disk group. We can have up to 5 disk groups per server. Okay, so this server here, I'm only showing you 1 disk group here. I could actually have up to 5. So that means if you do the quick math here, if I have 7 mechanical devices in each group, and there's 5 groups, 7 times 5 is 35. That's my capacity. I can have up to 64 hosts. So do your maths. 35 hard drives times 64 hosts. That's how big this vSAN data store is. Again, each drive group or disk group must have a cache device. Okay? So in this thing, I'm just showing you 1 disk group just to keep the picture nice and simple. So on my picture here, let's say for argument's sake, this cache disk is 1 terabyte in size. Let's say they're all 1 terabyte. 1 terabyte. 1 terabyte. And the capacity disks here, let's say they're 2 terabytes each. These are all 2 terabytes in size. 2 terabytes in size. So I got 4, 8, 12, 16 of them, right? So 16 times 2 terabytes. This vSAN data store would be 32 terabytes in size, minus a little bit for metadata and overhead and stuff like that. The cache disk does not add to the capacity, right? Okay, folks. So it's these drives here, and we'll talk about how we utilize this, right? So again, we have a capacity tier, which in this case is hard drives, our cache tier, which is a solid state or NVMe. I mentioned before you have 7 devices, capacity devices in a disk group, and you can have up to 1 cache drive, whether it's solid state or NVMe, per disk group as well. Max 5 disk groups per server and a minimum 3 hosts in vSAN. Technically speaking, I could do a two host vSAN. I'll show you that. It's kind of a special situation, right? But basically, at a minimum, you need 3. Okay, so we're taking these disks and pooling them together to make one big volume, and this one big volume is accessible by all of these servers. Okay, this is the hybrid disk group. There's also called the all-flash disk group, and you can kind of figure out that one. We still have our disk groups. We have our cache tier, which is still, again, solid state, NVMe, whatever, right? But then our capacity tier now is not using those slow spindle disks. They're using the solid state disk. Now, back here, when I say slow spindle disk, I'm referring to something like maybe SAS drives, SATA, but anyways, SAS, that type of thing, storage, serial attached storage, SAS or whatever, fiber, let's pass on that one. So over here on the all flash, you're dealing with all solid state drives, right? So one of them, again, in the disk group will be dedicated as a cache, and in this one, we use this for 100% of the writes, okay? And then we have our capacity drives are all solid state as well. Same kind of stuff applies, up to 7 capacity drives per disk group, up to 5 disk groups max per server, and maximum 1 SSD or NVMe for the cache, and again, minimum of 3 hosts. As I mentioned, the max is 64. But same kind of thing here. But this example here, it's actually going to be really, really fast. Now, one thing I didn't point out, let's back up a second, is the vSAN network. In the hybrid solution, we need, well, whether solution doesn't really matter. You need this vSAN network. Ideally, this is a dedicated network for the vSAN traffic, okay? For our storage traffic. In this example here, using the hybrid, since you have these slow disks here, a minimum you can get away with is 1 gigabit per second cards. So this would be a 1 gigabit per second. You probably have teaming going on here for redundancy. This would be a VM kernel port. Sort of like your vMotion, you create a VM kernel port connection and you say, I want to use it for vMotion. Same thing here, you go, I'm going to create a VM kernel port on this host and I want to enable it for vSAN. You'll see that in my demo, okay? Now, in this case here, if you decide that you're going to use 1 gig cards for whatever reason, this has to be a dedicated network for vSAN traffic and vSAN traffic only, dedicated cards from a support perspective, okay? When we talk about all flash, right? All flash disk groups, minimum is 10 gigabits. Okay, you go faster, no problems, right? So you really want to watch out for that. So you have this, again, this technically, if it can be a dedicated network for vSAN traffic, all the power to you. In this case here with the 10 gig, you could kind of mix vMotion traffic on it. There's actually a design guide that they talk about it. This could utilize either standard switches or vSphere distributed switches. You're better off with distributed switches because you can control the amount of traffic with network I/O control. That's a way of kind of prioritizing traffic across your cards. It's one way to look at it. Again, if you're not sure what I'm talking about with that, well, you got to watch my networking 101. So again, this all flash, again, we want 10 gig cards up here. Now, by the way, there is a hardware compatibility list that you require. So there are these things called vSAN ready nodes. These are nodes that are already been, these are blessed for vSAN and away you go, right? If you want to go that route, or again, your hardware has to be supported by vSAN. In a lab environment, who cares, right, folks? You can do what you want in a lab environment, but in production, you want to make sure you got the appropriate hardware per se. Now, this is new in version 8, in vSphere 8, this thing called Express Storage Architecture, or ESA. What they've done now, they made this faster. They talk about vSAN network requirements. It says minimum 25 gigabits per second or higher. Technically speaking, you could do it with 10. There are some cases where you can do this with 10 gig cards, but most cases it needs 25 gig or faster. What did they get rid of? We now, instead of called disk groups, we got server pool, storage pool. All the disks on this server is considered a storage pool. There's no more capacity, no more cache tier. So this is not a 2-tier solution. So this is a new in version 8. This is supposed to be faster, taking advantage of some of the more faster network cards and stuff. There are some requirements. As I mentioned, it's a single tier architecture. Right now, again, as of doing this recording, only vSAN ready nodes are supported, so there are only a handful of devices that are supported, so you want to watch out for that. Only SSDs here, no mechanical hard drives. And again, the nice thing here is no cache disk is required. The advantage, when I look at the cache disk, remember I said maybe this is a 2 terabyte disk, and these are all, or 1 terabyte, whatever the size is. That is space that you cannot use for capacity. So it's almost like you're kind of almost wasting storage, right? Whereas this solution, you don't have to worry about that extra overhead. So it actually does save you your capacity and stuff like that. Is it cheaper? I don't know. You guys have crunch numbers. I'm not a sales rep. So this is new, which is kind of nice. And I think this will be the dominant one moving forward. Today, as of doing this video, there's no way of doing a migration from the old version to this. This is a greenfield deployment, so brand new deployments only. I don't know if that's changed or not. The other advantage of this solution, remember I mentioned here, I can have up to 7 capacity devices per disk group. Each server can have up to 5 disk groups, so 7 times 5 is 35 hard drives. So 35 hard drives, that's my limit, 35 times 64 servers. There's my upper limit. This one here, technically, there really is no limit. There's 64 servers, but technically speaking, how many hard drives can you have inside a server? So it's not really a limit of vSAN per se, okay? All right, so there's a couple of ways we can deploy vSAN, okay? First is the single site, which is a very common use case. So you have a bunch of servers, again, typically minimum of 3, okay? I'm just gonna say minimum of 3, you can have more. And from there, these servers all have like drives inside them, you know, the cache drives or whatever. You have all your physical drives inside them. And then you're making your disk groups or storage pools, depending on if you're using ESA. And then you're actually creating your vSAN data store. Very common use case right here, okay, very popular. Then you have a 2-node cluster. So I said you can actually have just 2 nodes. This might be for some kind of like small solution with a branch office. And then you need, oops, let's back up here. And you need a witness appliance over here. And we'll see where the witness comes in when I start talking about policies and whatnot, right? Or failure to tolerate. Or when I get into policies. So we can do a 2-node cluster. Again, this might be a remote site, site A, you got 2 nodes, small environment. You got, again, maybe this is my head office where I've got my witness site. And at this point, you've got a shared storage between these 2 servers. I'm not sure how popular this one is, but I would imagine it's out there, right? This one here is actually popular, stretched cluster. This is actually interesting. You're going to create a vSAN data store across 2 different sites. Now, typically, these sites are going to have to be relatively close together. 5 milliseconds latency across that vSAN network. Okay? And you need a 3rd site to put a witness. The witness is basically there to provide for quorum. Well, for example, if this site here fails, how do I know which one is good? You know what I mean? Like, if I lose my connections here, right? That sort of thing. So the witness is there to provide for quorum, okay? And we'll see that when I talk about storage policies. But anyways, we'll leave it at that. There's another one called hyperconverge. Is it hyperconverge? No, mesh, ACI mesh. One of the things is you can actually use a vSAN data store and mount it in a different vSphere environment. I didn't put that up on here. I don't know how popular that is, but anyways, these are the 3 main common ones. And when you go to set it up, it'll ask you which one you want to do. I'll get a demo doing this one first, to be honest with you. That'll be my next video. So again, keep that in the back of your mind. This is very popular as well. I talk about this in our NSX class if you've ever seen that multi-site DR stuff. All right, so let's talk about storage policies. Let me just pause the recording for 1 second. Okay, let's talk about storage policies here. Now, before I do this, one of the things I mentioned was hyperconverge or HCI. That was way back here, right? Supports the hyperconverge infrastructure. What is that? To me, it's kind of a marketing term. Anyway, that's how I look at it. But VMware's definition is it's a software-defined unified system that combines all the elements of traditional data center, storage, compute, and networking management. Basically, in a nutshell, it's a way for us to virtualize all of those things that used to be physical in the past, right? I talked about virtualizing networking security, right, with NSX. We're talking about virtualizing storage now. We don't need a fiber channel SAN. We could use this vSAN, right? We talk and vSphere, your ESXi host, virtualize your compute, CPU and memory, your virtual machines. So that's kind of what a hyper-converged architecture is according to their definition. So I just wanted to point that out. To me, more of a marketing term than anything else. So let's jump back into this. Let's talk about storage policies. So we use this thing called storage policies to define your storage requirements of your VMs. What are those things? Do I want to do dedupe? Do I want to do compression? Do I want to do encryption on the VM? Do I want fault tolerance? That's probably the big one, right? I want to protect this VM from one host failure. I want to protect it from two host failures, that type of thing. What level of paranoia of failures are you with your VMs? And this is what we talk about in our storage policies. And I'll create a video on that because we could spend a fair amount of time. Each VM on a vSAN data store is assigned at least one policy. And you can give it the default vSAN policy, which is basically a failure to tolerate of 1, meaning I'm doing a mirror, which we'll show you. So we actually have, when we talk about policies, and I got some screenshots over here, and I'll demo this in a later video when we get deeper dives into this. When you get into policies, it's going to actually ask you 2 parameters: site disaster tolerance and failure to tolerate. So when we look over here on, which one's the site here? Oh, we got the same picture on both. That's really silly. I just realized that. 1 second. Okay, so I made a little mistake there on that picture. So we talk about site disaster tolerance. That's supposed to be a picture there. I just realized this. Let me just show you. Here we go. So under my policies, and I'll show you how to create this in a separate video. Under site disaster tolerances, you can say none. I don't have multi-site. I just have all my servers in one site, like that first example. Host mirroring, 2-node. Site mirroring, stretch cluster. None, keep all my data on the preferred. Keep all data on secondary, or none, stretch cluster. So I'll talk about these when we get more into creating policies later on. But again, this is kind of dictating, do I have a stretch cluster, yes or no? Do I have multi-site, yes or no? That type of thing, right? So we don't have that here in this example. But that's what that one policy is. Let's go into here now. Down over here, failures to tolerate. This is the number of failures you want to be able to withstand. Like how many disk failures / server failures do you want to be able to withstand? Failure to tolerate 1 is mirroring. So I'm going to have my data mirrored. So when something happens over here, my data is still here, my VM still runs, or the data is still accessible, I should say. Failure to tolerate of 2. Now I'm actually I'm doing like two-way mirror, right? So now I'm going to have 3 copies. So in case 2 copies fail, I still have a third. Failure to tolerate a 3. You're really paranoid, right? So I want to be able to withstand 3 failures. So I'm going to keep 4 copies, right? So if 3 copies fail, I still got back to my 4th copy, which I'm good, right? So you've got this level of protection that you want. This one here might be a little excessive, but hey, it's an option for you, right? Another one is failure to tolerate, which is RAID 5, or failure to tolerate, which is RAID 6. So again, you set up these policies and you assign these policies to your VMs. You need at least 1 policy assigned to your VM on a vSAN data store, at least 1, but you can actually have multiple different policies. I can have multiple disks on a VM. Maybe the boot disk, I want to do a failure to tolerate a 1. Maybe the data disk, I'm really paranoid, I'll do failure to tolerate a 3 or something like that, okay? So you have that as an option for you if you want to do that. So let's take a look at some of these policies here. So the first, well, I didn't really mention it here, but there's a failure to tolerate a 0. That's RAID 0. I don't want any fault tolerance. So the space required is 1 times the amount. So let's say my virtual machine here is going to have a 100 gig disk. That's the size. It's only going to use 100 gig of storage. So I don't care if there's a failure. I put this component down over on one of the drives. If something should happen to that drive, well, I lost all my data. Okay, that's failure to tolerate of 0, like you're doing RAID 0. So let's get around that one. This is a common one. This is a failure to tolerate a 1 mirroring. This is the vSAN default policy. The space required is 2. So again, if this VM has 1 gig in storage, 100 gig in storage, it's going to use up 200 gig of that big vSAN data store. And I put in 200 plus because there's a little bit extra here. So notice over here in this picture, I'm showing you 3 hosts. You need at least 3 hosts. Remember I said you could do a 2 hosts with a witness, so technically you could do that on there. But anyways, let's say you need a minimum of 3 hosts. What happens is remember your VM is an object. So it's virtual disk, it's swap file, a home directory, all that stuff. It's an object. We take that and that breaks down to like components. So we'll take, let's say, that virtual disk of the VM, make an object, and we'll keep a component copy of it here, let's say, another component copy of it here, and then we'll have a witness over here. Now you might be wondering what the witness component is all about. The witness component is there for a tiebreaker. In case something happens, it determines who's good, right? So let's say we lose a server here. So I lost that disk, okay? Well, we still have a copy of it over here, and we have the witness. So I have more. It uses a thing called votes. So I still have more than 50% of my votes available. I'll do a deeper dive. We'll look at components in a later video. But again, I still have redundancies here, and I'm still good. Now, one thing I will point out, let's say this host died. Remember, this is a VM, and this VM could be running on this host, or it could be running on this host over here. I don't care. So if this host dies, this VM is still running. It still has access to its data disk and the witness. So everything's okay. Life goes on, okay? But if the VM was running on this host and this host died, well, we lost that component and we lost our VM. But using vSphere's HA, that VM could start back up on one of these survivors, okay? Because the data is still there, right? One thing I do also want to point out is what happens if the cache device dies? This is kind of a bad thing. If the cache device dies in this disk group, I'm only showing you one disk group per server. These are my servers. I'm only showing you one disk group per server. Remember, you can have up to 5 per server. If this cache device dies, all these drives go offline. So essentially, they become inaccessible at that point until you fix this cache device. So that's kind of a gotcha, right? So maybe a good idea to have multiple disk groups, right? But then you need multiple cache devices. It's costing you a bit more for disks, right? So in case one cache device dies, it only affects that one disk group as opposed to the other disk group. Okay, so that's one thing you got to keep in the back of your mind. All right, so that's a failure to tolerate a 1 mirroring. Failure to tolerate a 2. Minimum number of hosts is 5. Okay, the space required is 3 times. I want to be able to withstand 2 failures. So let's say my disk is 100 gig in size. Therefore, I want to be able to withstand 2 failures. That means 1, 2, 3, 3 100 gig disks I need. So that's why we would need 300 plus space of storage. And you'll see over here, again, I'm showing you my 5 servers. And again, my object, let's say just my virtual disk here. Again, that's broken down. It's an object. It's broken down into components. And you'll actually see, again, one component over here on this server, another one over here. That's fine. Looks like I got another. Oh, sorry, that's wrong. Another component right here and another component. Let me check. Back to orange. Here and here. There's my components. But now I have 2 witnesses. Okay? And you might say, why do I need 2 witnesses? If they only had 1 witness, let's say I scratch that off, we have even numbers here, and we need some kind of odd number to guarantee quorum, right? We can't have 50% of the votes. We need 51%. So we need that extra little bit, right? So this is why we have that other witness over here. And again, these are all spread across these disks. Okay, you could view them if you want. I'll show you that in a later video when we do a deeper dive on this. So the nice thing about this one here is if I lose a server, so if all of a sudden I lose this server or that disk or whatever, right? And I could also lose, let's say, this server or this disk, right? and the VM could still operate because it's still got its component here, and there's 2 witnesses still, right? And everything's still good. If I lose more than that, if I lose 1, 2, 3, at that point I don't have 50% of votes, and this is not accessible anymore. Same thing in the previous example. I can failure to tolerate a 1. If I lose this, okay, I'm fine. If I lose that, I'm not fine. Even though, sorry, let me lose this. I lost that component, and I lost the witness. Okay, we don't have over 51%. We don't have 51% of votes. Even though this is a component here, this is not accessible anymore. We have to fix this. And I'll run through videos on replacing drives, troubleshooting, and all that stuff. But it's a bit much for now. That's failure to tolerate a 2. Mirroring the last one, failure to tolerate a 3. You need a minimum 7 votes. You're really paranoid here, right, on failures. So I want to be able to withstand 3 failures here. Space required is 4 times the amount. Remember, I want to be able to lose 3. So let's say I got my 100 gig disk, so I'm going to have 1, 2, 3 extras. So that's 4 times that. So I'll be using up to 400 gigs of storage, plus a little bit more because we have these witnesses, right? So you'll see, again, it's required is 7. We have a component here. We have a component here, and a component here, and I still have our witnesses. So we have odd numbers. And again, I could lose whatever, 1, 2, 3, and I'd still be okay. All right. Remember, if a server fails, if the VM's running on the server, the VM also fails. But again, HA could restart it back on a surviving host as long as we can still access the data, which is the important part, right, folks? So you have to keep that in the back of your mind. RAID 5. I may do a video on the different RAID levels, but anyways, failure to tolerate using RAID 5. Now, when I talked about the other examples, like failure to tolerate a 1, if I have a 100 gig disk, I need 200 gigs of storage. So that can get pretty expensive on all your VMs. RAID 5 doesn't require that level of expense, right? We need a minimum of 4 servers. Now, I remember the first time I was introduced to vSAN. I know RAID 5, I've been playing with the stuff for decades, right, since my IBM days. And typically with RAID 5, you just need 3 hard drives, right, at a minimum. So when I saw this, you need 4 servers. It kind of baffled me. This is just the way VMware implemented vSAN. They're saying, we're going to use RAID 5, and you need a minimum of 4 servers. That's it. Even though RAID 5 can go on 3 hard drives, again, just forget about that part of RAID 5. We need, in a vSAN environment, you need at least 4 servers. So what's happening here is we're going to take our data. So from a RAID 5 perspective, I have my data, and I'm going to slice that data up into blocks, let's say. So I'll have data 1 here, data 2, data 3. Then I'll have a parity of that data. Then my next stripe, I'll have a data 4, 5, and a data 6. And I have the parity. This is called skewing the parity. See how the parity is being skewed across disk? We don't have, if you're familiar with like RAID 4, you had a parity disk, all the parity be on one disk, right? We don't do that. We skew it. And that's kind of what's going on underneath the covers here on your disks in your vSAN storage, right? I kind of just do this just to kind of illustrate this. Now, if you don't know what a parity is, let's just do a practical example here. Let's say data 1, let's say this is the value of A. Data 2 has a value of B. Data 3 has a value of C, and parity is a value of X. So basic mathematics, let's say I say X is equal to A plus B plus C, right? Okay. So now if all of a sudden I lose this here, what did I lose? I lost B. Well, B is equal to X minus A minus C, right? So pretty straightforward. So the advantage here is the space required is 1.33 times, hey, what happened to my pen? Space required is 1.33 times the amount of space you need. So for example, my 100 gig VM here would only need 133 gig, as opposed to if I was doing failure to tolerate of 1, I would need twice that space. I'd need 200. So this can save you a lot of space. Now, the beauty of this is you could do this on a per VM basis, right? What's the downside of RAID 5? The downside of RAID 5 is, when I just talk about RAID 5 in general, when you make a change to a data block, you also have to calculate and make a change to the parity. So if I change data 1 here, I got to calculate and change this parity. If I make a change on data 8 here, I got to calculate and change the parity. If I make a data change here on data 12, I got to calculate and change this parity. This calculation and changing takes time. So therefore, RAID 5 basically has the wrap of we talk about writes, the performance is usually not that good. So if you've got VMs that are very, very write intensive, RAID 5 may not be your choice. Whereas mirroring is easy. I just make a copy, boom, boom. It's like photocopying, boom, boom. It's easy. It's a no-brain concept, right? So, so that's kind of one of the advantages of RAID 5. It's saving space, but it also potentially, performance-wise, it's not as good, let's say, as the others. How about this other one here? Failure to tolerate a 2, and we want to do RAID 6. Okay, so in a vSAN environment, you need a minimum of 6 hosts. So we're going to spare that data across the 6 hosts. The space required is 1.5 times. So it's better than failure to tolerate 2 mirroring, because I would need 3 times the space. So if I have a 100 gig disk, I'd need 300 gigs of storage. Whereas this one here, 100 gig disk, I just need 150 gig of storage to provide protection and give me that same level of failure to tolerate. This is basically the same kind of thing. We're striping our data across these disks. Okay, and you'll see over here with RAID 6, what it is a double pair. Think of it as a double parity RAID 5. So we got our data 1, data. Oh, I got data 1. This should be data 1, data 2, data 3, data 4, and then I got my parity and a parity prime. Okay, then I have my data 5, data 6, data 7, data 8, and I get my parity 2 and parity 2 prime. So the advantage here is if I lose any 2 of these, I can still figure out those values by looking at this data, that data, and my 2 parities. If I lose more than this, if I lose 1, 2, 3, I cannot calculate all those by looking at these. Same thing back here on RAID 5. If I lose 1, I'm okay. If I lose 2, I'm dead in the water. I can't calculate all those failures, okay? So that's RAID 5 and RAID 6. Again, these are the requirements that you need, a minimum number of servers. And that's it. Thanks very much for watching. Hey, if you stuck around this far, hit that thumb up button if you found it entertaining. Subscribe to the channel if you haven't already done so. My next video will be setting up vSAN, so stay tuned for that. So this is part 1. That will be part 2. It'll be coming up very soon, and I'll show you how to do that a couple of different ways, all right? So thanks again. We'll see you in the next one. Bye for now.